This is a very challenging problem here, and we're going to start off by writing this out as a limit in a little bit longer form. So limit as h approaches 0 of e to the x plus h minus e to the x plus e to the x minus e to the h. Now this has not changed anything in our problem because we're adding and subtracting the same quantity here in the middle. Well, now we're going to go a step further and try to break this up into two limits. It's the limit as h approaches 0. I'm going to take the first two terms and write them as a fraction plus the second two terms writing as a fraction also, which to begin with may look like it's very confusing and not necessary, but I think it's going to become much easier as we look at it here, because now when we look at this first limit here, we hopefully can look at that and say that's the definition of the derivative. So that means that our function is e to the x. So essentially this is just saying, what is the derivative of e to the x? The derivative of e to the x is e to the x. Alright, and then when we come to this second, even though it doesn't look exactly like it, excuse me, I left off two things up here, that's x minus h. Even though it doesn't look exactly like it, if you look, you notice that we are, this quantity, the second quantity, is h less than the first quantity in this fraction, just like it is in the first fraction. So it really is the definition of the derivative again, and we get e to the x with this one also. So both of them are simply asking what's the derivative of e to the x. And if we take one e to the x and add another e to the x, we get 2 e to the x.